Okay, let's dive into this. Today, we're exploring a creature that literally looks like it swam right out of a comic book and straight into a coral reef, the mantis shrimp. Now, at first glance, you might think this beautifully colored crustacean is just a vibrant, harmless little resident of the ocean floor. But beneath that colorful exterior, oh man, lies a creature wielding biological weapons and sensory systems that absolutely baffle the scientific community. In this explainer, we're going to focus intensely on two super specific things: the mind-bending physics behind its high-velocity punch and the extraordinary, honestly almost alien complexity of its visual system. Get ready, because the things this animal can do, they completely break all the rules of what we think is possible in biology.
Just a few inches. That's the massive contrast we're dealing with here. The mantis shrimp is tiny. If you held it in your hand, which actually scratch that, as we'll soon see, you should absolutely never ever do that, but if you did, it would easily fit right across your palm. Yet when scientists first started measuring its power, they literally refused to believe the numbers popping up on their screens. Despite being only a few inches long, this creature generates enough localized kinetic energy to smash open hard crab shells, obliterate thick sea snails, and get this, even shatter solid aquarium glass. I mean, keeping them in research labs is a genuine logistical nightmare because they have a habit of literally punching their way out of standard glass tanks. So, how does a creature the size of a candy bar hit with the force of a low-caliber bullet?
Well, to truly understand this power, researchers had to record the strike using ultra-high-speed cameras inside advanced scientific labs. And when you slow that footage way down, a terrifying four-step sequence emerges. First, the creature's club-like appendage strikes the water, moving way faster than most human punches. Second, because that appendage is moving with such extreme velocity, the water immediately surrounding the club drops in pressure so rapidly that it briefly turns into vapor. It literally boils the water around it through speed alone. Third, as that vapor cavity collapses, it forms a massive shockwave. And fourth, the collapse is so incredibly violent, it actually produces a brief, literal flash of light. No way, right?
Let's break down the exact physics of what we just saw, because this is absolutely crucial to understanding the mantis shrimp's lethality. This phenomenon is called cavitation. Simply put, it's the rapid formation and collapse of vapor bubbles in a liquid due to extreme high-velocity movement, which creates intense shock waves. Basically, this tiny shrimp hits so unbelievably fast that the water around its fist literally explodes. It's a double-strike weapon. So if the initial physical punch somehow misses the crab or the snail it's aiming for, doesn't even matter. The resulting shockwave from that collapsing cavitation bubble is usually powerful enough to stun, dismember, or kill the prey anyway. It's quite literally a biological blast radius created entirely by kinetic speed.
Okay, so we have an incredibly small creature that can punch so fast it vaporizes water and shatters glass. I mean, that alone secures its spot as an apex micropredator, right? But here is the truly terrifying question. What makes this animal even deadlier? Because believe it or not, the explosive, water-boiling punch is not even the strangest or most advanced part of its biology. Think about it. A weapon is really only as good as the targeting system that directs it. And the mantis shrimp's targeting system? It's completely out of this world. That brings us to its supervision. The mantis shrimp possesses one of the most complex visual systems ever discovered in the entire animal kingdom. When you look closely at a mantis shrimp's face, you'll see these two strange, multifaceted stalks, and they move completely independently of one another. They look exactly like little alien periscopes, just scanning and tracking the environment. So while the rest of the animal's body is built for sheer explosive physical power, its eyes are a delicate, intricate masterpiece of sensory engineering.
And this brilliantly illustrates just how staggering the contrast is between us and them. Human vision relies on a very limited range of color receptors, just 3 to be exact: red, green, and blue. Think about that for a second. Every beautiful sunset, every piece of art, every single color you have ever perceived in your entire life is just a combination of those 3 little receptors. But the mantis shrimp? It possesses a massive, highly complex spectrum of color receptors. Researchers cite them as having up to 12 to 16 different types of photoreceptors. So while we humans are walking around seeing an incredibly limited slice of reality, the mantis shrimp experiences the ocean in a totally different way. They are seeing this wildly vibrant, data-rich environment full of wavelengths, ultraviolet light, and polarized light that our brains simply cannot even begin to compute.
Now you might be wondering, okay, why does this matter to us, other than being a really cool piece of trivia? Well, it matters deeply to modern technology.
Scientists aren't just looking at these creatures and saying, wow. They're actively studying mantis shrimp eyes in high-tech laboratories to reverse engineer their capabilities. Decoding this supervision is directly contributing to improving future cameras, making them able to detect cancers or map environments in ways that our current lenses just can't. It's helping to develop next-generation optical sensors, and it's advancing the whole field of bio-inspired robotics, giving autonomous machines a much richer, way more complex way to see and navigate the world around them. It's a real game changer.
So the crucial point I want you to take away from this explainer is this. The next time you see footage of a tiny, colorful shrimp hiding out in a coral reef, remember what it is truly capable of. You are looking at a creature carrying one of the fastest, most destructive punches in existence, guided by one of the strangest and most advanced visual systems in the entire animal kingdom. It is a total marvel of evolutionary physics and biology. But hey, the ocean is full of rule breakers. If you think boiling water with a punch and seeing invisible colors is incredible, wait until you meet the ocean animal that can change both its shape and its color in mere seconds to disguise itself as entirely different species. We'll be exploring the absolute magic of the mimic octopus next time. So, what other unbelievable secrets is the ocean hiding? Stay curious and we'll find out together.